sklearnmultioutputMultiOutput classifier. Description: explain in detail. The multi-output classifier is a scikit-learn estimator that combines multiple estimators to predict multiple target variables, each of which may be a different type. It handles multi-output classification problems, where each sample has multiple target variables, each of which can be a discrete label. Inputs. Input 1. Explain in detail the input data. Typically a 2D array of shape n samples. N features, where each row represents a sample and each column represents a feature. This data should be compatible with the chosen base estimator. Input 2. Explain in detail the target data. A 2D array of shape n samples. N outputs, where each row represents a sample and each column represents a target variable. The target values should be discrete labels for each output. Outputs. Output 1. Explain in detail a 2D array of shape n samples. N outputs, containing the predicted target values for each output. Output 2. Explain in detail each element in the output array represents the predicted label for the corresponding output variable and sample. Steps. Step 1. Explain in detail. The multi-output classifier takes an array of estimators as input. Each estimator is used to predict a single target variable. The estimators can be of any type that supports the fit and predict methods, such as decision tree classifier, random forest classifier, or logistic regression. Step 2. Explain in detail during training. The multi-output classifier trains each estimator independently on the corresponding target variable. Metrics. Metric 1. Explain in detail. Accuracy measures the proportion of correctly predicted labels for each output variable. It's often calculated as the average accuracy across all outputs. Metric 2. Explain in detail. F1 score measures the harmonic mean of precision and recall for each output variable. This metric is useful for imbalanced datasets. Visualization plots. Visualization plot 1. Explain in detail confusion matrices for each output variable. A confusion matrix can visualize the performance of the classifier by showing the number of true positives, true negatives, false positives, and false negatives. Visualization plot 2. Explain in detail feature importance plots. If the base estimators support feature importance, you can visualize the importance of each feature for each output variable. Fine-tune parameters. Parameter 1. Explain in detail estimator parameters. You can fine-tune the parameters of the base estimators used within the multi-output classifier, such as the number of trees in a random forest classifier or the regularization strength in a logistic regression. Parameter 2. Explain in detail n jobs. This parameter controls the level of parallelism in the training process. Setting it to -1 utilizes all available CPU cores for faster training. Uncertainty methods. Uncertainty method 1. Explain in detail confidence scores. Some base estimators, like logistic regression, provide confidence scores for each prediction. This can be used to estimate uncertainty. Uncertainty method 2. Explain in detail ensemble methods. Using an ensemble of estimators within a multi-output classifier, such as random forest classifier, can provide an indication of uncertainty through the variance of predictions across different estimators. Challenges and fixes. Challenge 1. Explain in detail data imbalance. If the target variables have unbalanced classes, the performance of the multi-output classifier might be biased towards the majority class. Sample use case that resulted in challenge 1. A dataset with a target variable where one class has 90 of the data and the other class has 10. This might lead to the classifier predicting the majority class more frequently. Fixes to challenge 1. Use cost-sensitive learning. Assign different costs to misclassifications to penalize errors on the minority class more heavily. Oversampling. Increase the number of samples from the minority class to balance the dataset. Undersampling. Decrease the number of samples from the majority class to balance the dataset. Challenge 2. Explain in detail high dimensionality if the number of features is very high. The multi-output classifier may suffer from the curse of dimensionality, leading to poor performance. Sample use case that resulted in challenge 2. A dataset with thousands of features but a limited number of samples. Fixes to challenge 2. Feature selection. Reduce the number of features by selecting the most relevant ones for each output variable. Dimensionality reduction. Apply techniques like principal component analysis (PCA) or linear discriminant analysis (LDA) to reduce the dimensionality of the input data.